In chapter 1-4, we see that we're going to be solving absolute value equations. So now, what is absolute value? Well, absolute value is just a difference, the distance, from 0 to any number on a number line. And so let's say, for example, I have a -4. Well, the absolute value, and we denote absolute value with these bars here, the absolute value of a -4 is just the number 4. And of course, the absolute value of 4 is 4. So we're dealing with what is the distance from the origin, from 0. So let's say if I ask you to evaluate 8.4 minus the absolute value of this expression here, if I say n is equal to -7.5, then just substitute for the n, which is what I've done here. I placed the -7.5 for the n, and I continue solving. So absolute value is the part that you solve first. So take care of all the inside. 2 times -7.5 is -15, and then you have that plus 5 there. So then -15 plus 5 should give you -10 inside the absolute value. So now we're dealing with 8.4 minus the absolute value of a -10. Well, we already said that absolute value is just a measure of distance. So it's neither positive or negative, it's just the number, right? So the number here would be 10, but there is already a minus here. So we actually end up with 8.4 minus, this disappeared because of the absolute value. So we just have 8.4 minus 10. And so in this particular case, the 10 is larger and it's negative. So we subtract these, then you end up having -1.6. So sometimes when you do problems and you don't have an answer to or a solution to a problem, you say that you have an empty set. So you put 2 brackets like this, or this kind of 0 with a line going through it. And so be very careful, because if you don't have a solution, don't put 0, because 0 is an answer, right? 0 is a number. And so we don't want to put 0. We want to put either empty set, that there's nothing, or this symbol right here. So just be careful about that when you have something that has no solution. Call it an empty set. So now let's look at some of the problems you're going to be working on and examples dealing with absolute value. So if you'll notice, there is a key concept here in your packet that for any number, a, right, that you have that is positive or 0, the absolute value of a is a. If it's negative, the absolute value of a is the opposite of the a. So remember, if you have a -4, the absolute value of -4 is just the 4, or the absolute value of +4 is just 4. So that's just something to keep in mind when it comes to absolute value. Here are some sample questions. I already worked out an example similar to example 1. So I'm going to continue on to some of the others. Now, there is a situation where you have 2 possible cases, because, for example, in this particular equation here, you have the absolute value of y plus 3 is equal to 8. But see, we don't know is y plus 3, was that a positive number or a negative number? So you have to work it using both cases. You pretend that, hey, maybe what if that this left side here was negative or it was positive. So that's why you end up with having 2 cases. So let's see what they did here. So case number 1 is that you have a positive situation, but what if you had a negative situation? What if this stuff here was -8? Because if this inside the absolute value was -8, the absolute value of -8 is 8. So this could have been a -8 in here. So we're doing y plus 3 can be +8, or y plus 3 can be -8. So you solve both sides, and you end up with either y is equal to 5 or y is equal to -11. Well, when you substitute it back in, because we're not sure what if one works and one of the other one doesn't, right? So we substituted the 5 back in. 5 plus 3, you get 8. So the absolute value of 8, yes, it is 8. So this one works out. Let's try the -11. So if I have y equal to -11, plug it in. -11 plus 3 is -8. Is the absolute value of -8 8? Yes, it is. So therefore, this particular problem has two solutions. And you're going to see some more examples showing you that. Here they test the solution in this one, and notice how only one of them works, the other one doesn't. So just be very careful when you are doing these type of problems and trying to find which of these work. Then if you notice the study guide and intervention problems, they give you some notes here and two examples. Go over the examples, try to work them on your own. See if you can do that. So let's go ahead and look at this here. So let's do problem number 3. And it says, so evaluate each expression, but they give you particular numbers for the letters. So I'm going to plug in stuff. So this actually turns into 5 plus the absolute value of W, which is -4, plus Z. And you remember plus a -6, right? So you can go ahead and write both symbols down, because if you'll remember, positive times a negative becomes a negative. So you actually have here 5 plus the absolute value of -4 minus 6. We continue solving this, and so we always go inside the absolute value first. So inside here, I know I'm going to have -4 and -6. I get -10. Remember, you're adding them. This is not multiplication. And so therefore, I really have 5 plus the absolute value of a -10. Well, remember, absolute value means just the number. So just the 10, you know, like you don't have that negative anymore. So 5 plus 10 gives you 15. And therefore, that is your answer for number 3. So when you work these, show your work so that your teacher can grade you accordingly. And then in the next sheet, you'll have some more examples. But here now, you'll be looking at the 2 possible cases. So that way you can continue checking and working on these. So let's do another question. Let's try number 5, which has an extra little step here. So in this particular case, first I want the absolute value here by itself. So I'm going to move this guy over here. If it was positive 16 on this side, it becomes -16, or just subtract 16 from both sides. So I should end up with the absolute value of 5b plus 9 should equal to 2 minus 16, so that would be -14. Now remember, let's look at this particular case, because can anything that I take the absolute value of, can it ever be negative? So I think for this particular question, we're going to end up with no solution, because I can never take the absolute value of something and make it turn -14. And so we're going to go ahead and put empty set here for this particular question. So now let's go over to the practice section of 1-4, and let's do something like question number 21. So if you notice, question 21 is a little more complex because it has this additional 2p on this side, but we still use the same process. So let's go ahead and look at the 2 cases. So the first case is where we have to check that 8 plus p is equal to 2p minus 3. But then we also have the case where that 8 plus p can be the negative of that. So if I distribute a negative to both of these, then I end up with a -2p plus a 3. All right, so let's solve for these 2 cases right here. So in this case, I'm going to bring my 2p this way, which brings it -2p. And so therefore on this side, I'm going to end up with 8 minus p is equal to the -3. And then I can move the 8 to this side, becomes a -8. So I end up with -p is equal to, I add these 2 together, -8 and -3 is -11. I multiply or divide both sides by -1. Why? So I can get rid of the negative. So I just end up with P equaling to the number 11. Now what I can do is go back to the original equation and check to make sure that this works, because I might get a different answer on this side. So let's go ahead and check if it works. So if I were to place an 11 here and an 11 here, I get 8 plus 11, I get the absolute value of 19, which is 19. And let's check if it equals to what I have on the other side. Well, 2 times 11 is 22, and 22 minus 3 does give me the 19. So it looks like the 11 does work. And so now let's see if the other equation gives us a different answer. Same process, so now I'm going to move my 2p this way, becomes a positive 2p because of that negative that I had there. And so this gives me on this side 3p is equal to, and the 8 has to come over to this side, becomes a minus 8. So 3 minus 8, I get a negative 5. It looks like I'm going to end up with a fraction. So p equals to negative 5/3. But if you plug that in here, like I did the 11, you're going to see that that doesn't work. So the only possible answer is going to be 11.